Next up is problem number 2. This one is a little harder than question 1, but it's still doable. I'll show you how. So your first step is to find the impedance of the capacitor right here. Doing so gives you negative J40 ohms, and then you would combine that impedance with the impedance of your resistor right here. They are in parallel, so you use your parallel equation and get 16 minus J8 ohms. Moving forward, what I would do next is find the impedance of the inductor right here, J18 ohms, and then do a source transformation, turn this current source into a voltage source. Doing so will put this parallel impedance that you would have here into series with the impedance of the inductor. That means you can just add them together and get an equivalent impedance of 16 plus J10 ohms. Next up, you're just going to turn that voltage source back into a current source, making your impedance along this side of the circuit in series with your 4 ohm resistor right here. So you can just add them again, getting a Thevenin equivalent impedance of 20 plus J10 ohms. Doing so also gives you the Thevenin equivalent voltage of 63.6 angle negative 32 degrees. Next up, we need to find the maximum average power, which, if you remember, is just the RMS voltage squared over 4 times the resistance. To find the RMS voltage, you just take that 63.6 from your Thevenin equivalent, divide it by root 2, and square it. Then you divide that by 4 times your resistance, which is 20. So 4 times 20 is 80. Divide that, and you get 25.3 watts. So, still pretty easy. That's your maximum average power, and all the steps along the way gave you the impedance L and the impedance Thevenin and the voltage Thevenin. So